So imagine it's 1831, and one of the absolute most brilliant mathematical minds of the 19th century is dying in Paris. And in secret, she's writing this manuscript that's attempting to do the completely impossible. She is trying to unify the entire universe.
Yeah, and the crazy part is almost nobody even knew it existed at the time.
Right. It's honestly like stumbling across, I don't know, a hidden map tucked away in some dusty archive, a map pointing toward a treasure that the rest of the scientific world hadn't even, begun to look for.
It really does have that exact atmosphere of like a profound, almost whispered revelation. And I think what makes it so compelling is that she was pulling together these threads from just completely disparate fields of study, trying to weave them all into a single fabric right before her time ran out.
Well, welcome to this deep dive. Today we are exploring a truly fascinating and frankly mysterious document attributed to the mathematician Sophie Germain.
Yeah, written right near the end of her life.
Exactly, written between 1829 and 1831 under this just incredible title, On the Hidden Unity of Forces and Forms. And our sources for today include the main chapters of this massive philosophical treatise, but also a deeply personal collection of her private fragments, her raw calculations, and even these unsent letters.
And our mission for this deep dive is to really unpack what amounts to Germain's grand, unified theory of everything. We're going to explore how she connected the abstract world of mathematics, the actual physical forces of the universe, and, this is the wildest part, the human mind itself, into one single vibrating reality.
Which is just a massive scope.
It really is. And crucially, we're going to look at what her insights can teach you, the listener, about how to perceive the hidden structures in your own work and, well, your own life.
Because the contrast here is just staggering. I mean, we are talking about someone who spent her entire life studying hyper-specific things like the intense localized math behind vibrating metal plates or the highly theoretical distribution of prime numbers.
Right, very niche topics for the time.
Yeah. So how does someone in that position suddenly decide to just zoom out and write a unified theory of the entire universe? That's a massive leap.
It is a huge leap. But to understand it, we really have to look at the context of Germain's life at this exact moment. She is aging. She is in a steep physical decline, dealing with a very painful illness that she knows is likely going to be the end of her.
Wow, so she's working against the clock.
Exactly. But she possesses this mind that absolutely refuses to stop working. She literally writes in the fragments that her body is a mechanism approaching exhaustion, but her mind still resonates. And she says to silence it prematurely would be an act of violence.
That is such a powerful way to put it.
Isn't it? So this manuscript is her final grand attempt to show that all her fragmented pursuits over the decades weren't actually separate fields of study at all. They were, in her beautiful phrasing, apertures onto a single truth.
Apertures onto a single truth. Man, I love that. So, to understand Germain's universe, we first have to understand her view of mathematics itself, which, strangely enough, starts with a pretty bloody moment in ancient history, right?
Yeah, it starts with the death of Archimedes.
Right. So Germain shares this defining anecdote from her childhood. She's a 13-year-old girl, and she's confined to her father's library. She's basically hiding there to escape the absolute chaos and terror of the French Revolution that's just raging outside in the streets of Paris.
A pretty intense environment to be reading math history.
Seriously. And while she's hiding among all these books, she reads this story about the ancient Greek mathematician Archimedes. During the siege of Syracuse, a Roman soldier bursts in to kill him, but Archimedes is completely absorbed in these geometric circles he's drawing in the sand.
He doesn't even look up.
Right. His famous last words are, "Do not disturb my circles," and then, the soldier strikes him down.
And what's fascinating here is how the young Sophie Germain interprets this event. She weeps over the story, but, and this is key, not because of the violent death itself.
Wait, really? Why does she cry then?
She weeps because she has this profound revelation about the actual nature of reality. She realizes Archimedes wasn't defending scratches in the dirt. I mean, the sand is impermanent. His physical hand drawing the shapes was flawed. Archimedes was defending the perfect circles.
Oh, I see. The idea that he was protecting something immortal.
Precisely. He was defending objects that exist in an objective, immortal reality that Roman swords literally cannot touch. And from this, Germain argues that math is discovered, not invented. It's not just a human convention.
Meaning we don't just make it up as we go along.
Right. Think about it this way. If math were merely a convention, we could just collectively decide to change it. Like we do this with traffic lights. We decided that red means stop and green means go.
Sure, we could swap those tomorrow if everyone just agreed.
Exactly. But we literally cannot even conceive of a universe where 2 plus 2 equals 5. The math resists our will. It exists entirely independently of us.
Okay, hold on though. If this, let's call it a third realm of perfect circles and prime numbers, isn't just an invention in our heads, but it isn't physical matter we can touch either, where exactly is it?
That is the big question.
Right. Like, are we talking about some mystical heaven of floating shapes? Because to me, discovering math sounds less like, building a city from scratch and more like exploring a newly discovered continent.
That continent analogy is incredibly accurate to her worldview, actually.
Yeah.
It's not a mystical heaven of physical shapes. It's a realm of relations and structures. It's this infinite web of logic.
A web of logic.
Yeah. Like when you have a right triangle, the relationship between its sides is fixed by the Pythagorean theorem. That structural relationship exists whether humans are here to think about it or not. And this actually explains a phenomenon that is very familiar to all of us. Think about the last time you're trying to learn something incredibly difficult, grappling with a complex problem, and suddenly, click, you had that aha moment.
Oh, yeah. The moment where it all just finally falls into place.
Germain would say you aren't just memorizing data in that moment. During that flash of insight, your mind is acting as an aperture. You are aligning with this third realm, allowing eternal structural truths to pass through you. You are basically catching a glimpse of the continent.
So the light that passes through us is not our own.
That is wild. So, okay, if math exists in this abstract, immortal third realm of structures, how does it interact with the physical stuff we can actually touch and feel? Because as I understand it, Germain found the answer in a pile of vibrating sand.
She did. This is where we get to the famous Chladni figures. Right, Ernst Chladni. He was a physicist who did these spectacular public experiments. You take a thin metal plate, cover it in a fine layer of sand, and then you take a violin bow and draw it across the edge of the plate to make it vibrate.
And the result is basically magic to anyone watching.
It really is. When you do this, the sand magically dances and forms these incredibly complex, beautiful, symmetrical geometric patterns. The sand gathers along the nodal lines, which are the parts of the plate that are perfectly still amidst all the vibration.
And the French Academy of Sciences was so totally baffled by this that they offered a prestigious prize to anyone who could mathematically explain why these specific beautiful patterns were forming.
And most people thought it couldn't be done, right?
The greatest mathematicians of the time thought it was impossible to calculate. But Germain spent years on it, working in near total isolation, and she eventually won the prize. She derived an incredibly complex equation that proved these patterns weren't being imposed onto the plate from the outside by the bow.
Wait, so the pattern was already sleeping inside the metal, just waiting for the vibration to reveal it.
Exactly. And to understand why this was considered impossible to solve, we have to look at the math of movement. If you're tracking an object, its speed is the first derivative. Its acceleration is the second derivative.
Okay, standard physics stuff.
Right. But Germain wasn't just tracking an object moving in a straight line. She was trying to mathematically describe a stiff metal plate buckling, warping, and resisting in 3 dimensions. To do that, you need a fourth-order derivative.
A fourth-order derivative.
Yeah, you are essentially calculating how the curvature of the material is itself curving. It's a mind-bending level of mathematical complexity for the early 1800s. The vibrations simply made visible the mathematical laws that were already resting inside the material.
That is just brilliant. And this is the jumping off point for Germain's wildest leap, isn't it? She takes this concept of a vibrating metal plate and just scales it up to the entire universe. She proposes that empty space isn't empty at all.
That's right. She looks at Isaac Newton's idea of gravity and just rejects it entirely.
Really? She goes after Newton.
She does. Newton basically said that the sun pulls on the Earth across millions of miles of empty space instantly. It's often called spooky action at a distance, like there are invisible strings pulling objects together.
Right, which always sounded a bit magical anyway.
Exactly. But Germain argues that space itself is a mathematical medium. Think of it more like a trampoline bending under the weight of a bowling ball. Gravity isn't an invisible string. It's a local disturbance in this mathematical field spreading outward.
Hold on. Is she basically predicting modern field theory and relativity decades before Albert Einstein?
In a conceptual sense, yes. It is stunningly prescient. She is attempting to unify gravity, magnetism, electricity, and elasticity, suggesting they aren't separate, unrelated forces at all.
They're all the same thing.
She says they are just different modes of vibration in a single underlying mathematical substrate. She even makes this incredible prediction that all fundamental forces must propagate through this medium at the exact same finite speed, which she suspects is the speed of light.
That level of foresight in the 1830s is just wild. But how did she even arrive at that? Did she mathematically prove all of field theory by herself?
And that's the crucial part. No, she didn't deduce this from pure rigid logic. She guessed it.
She guessed.
She used physical observation, trial and error,
Hmm.
and massive leaps of intuition. She writes that she simply felt the fourth-order derivatives captured the physical reality of the bending plate.
She felt the math.
Exactly. Her process proves that in science, and really in any kind of problem-solving, discovery often precedes formal justification. The intuition comes first. The proof is just the scaffolding you build afterward to hold the idea up so others can see it.
Okay, so if Germain believed in this perfectly unified, symmetrical universe that's woven together by mathematical vibrations, how did she handle the parts of reality that are famously chaotic, like the anomalies that just refuse to fit into a neat, symmetrical box?
That tension is exactly what drove her toward prime numbers.
Right, primes. They are essentially the atoms of arithmetic. Because of the fundamental theorem of arithmetic, every single whole number you can possibly think of is just a combination of prime numbers multiplied together.
Yep, the building blocks.
Like, take a number like 12. That's just 2 times 3. Primes are the uncuttable building blocks of reality. They are divisible only by 1 and themselves, and Germain was totally obsessed with them. In fact, a specific type of prime is still named after her today, Sophie Germain primes, which follow the formula of 2 times a prime number plus 1.
They're a huge deal in cryptography today, actually.
Yeah. But what drove her crazy, and honestly what still drives mathematicians crazy today, is the contrast between how simple primes are to define and how totally chaotic their distribution is along the number line. You just can't perfectly predict where the next one will appear.
There's a brilliant, deeply evocative fragment in her private papers about this fragment before. It describes a dream she had.
Oh, the dream is so cinematic. She dreams she is wandering through this vast, infinite hall of integers. And in this hall, the composite numbers, regular numbers like 6 or 8 that can be divided up, are solid, impassable walls.
But the primes are different.
Right. The prime numbers are doors. They're openings leading to unseen, hidden corridors of the universe. It sounds like she views primes as the fundamental source code of reality.
Viewing them as the source code is a perfect modern analogy, and she finds a similarly frustrating anomaly in the physical world when she looks at the concept of heat.
How so?
Well, she notes that her wave equations, the math describing the vibrations of those metal plates, are completely reversible in time. If you record a video of a vibrating string and play it in reverse, it looks like normal physics.
Sure. It just goes back and forth.
Fourier's heat equation is irreversible. If you play a video of an ice cube melting backward, it makes no sense. Heat only ever flows from hot to cold. It never, ever spontaneously runs backward.
So heat acts as the ultimate arrow of time. But wait, if she believes that all is one and everything is this beautifully unified, vibrating web, how does she reconcile these irreversible, chaotic anomalies like prime distribution and heat flow with her perfect mathematical universe?
This is where her mindset becomes incredibly instructive for all of us. She doesn't hide from the anomalies. She embraces them as cracks in the edifice.
She leans into them.
Exactly. She views the unpredictable primes and the irreversible flow of heat not as failures of her theory, but as the most exciting places for future discovery.
Oh.
She writes that these cracks are exactly where new physics and new math will eventually be found.
That makes a lot of sense.
Yeah, and when you are studying something or trying to understand a complex system at work, the places where the information doesn't neatly fit together shouldn't discourage you. Those points of friction are exactly where you have the greatest opportunity for genuine breakthroughs.
Follow the friction. That's a great rule of thumb. But, this leads to a really fundamental philosophical hurdle.
What was that?
We've established this grand universe made of mathematical fields, prime number source code architecture, and vibrating forces. But how is a fragile, finite, wet, biological human brain capable of understanding any of this immortal math? Like, how does the meat in our skulls grasp the eternal?
How does biological matter comprehend eternal truth? Germain's theory of mind here is just breathtaking. She argues that the mind doesn't just sit outside the universe observing it like a spectator looking through a window. The mind is a mathematical structure itself.
Wait, our brains are math.
It is woven from the exact same fabric as the universe it is trying to understand.
So how do we actually learn things, in her view? How does the connection happen?
Through what she calls resonance or sympathy. Because the mind is a mathematical structure. We don't just, memorize a truth. She uses the concept of being isomorphic, meaning our brain structure temporarily takes on the exact same shape as the truth itself.
Oh,
Yeah, our
wow.
minds literally resonate with the shape of the mathematical reality, just like the metal plate resonating with the frequency of the violin bow.
That makes the act of learning sound almost like an act of physical tuning, like plucking a guitar string and watching the string next to it vibrate in sympathy.
That's a perfect way to visualize it.
And this is why she values intuition so highly, right? She says intuition is the driving force of discovery. But wait, if she thinks mathematical proofs are just scaffolding, isn't that incredibly dangerous? I mean, if we just rely on vibes and intuition, we could completely fool ourselves into believing a mirage.
She absolutely acknowledges that danger.
Hmm.
She says human perception is deeply fallible. We can see mirages, our intuition can misguide us based on our biases. That is precisely why proof is necessary.
Okay, so she doesn't throw proof out the window.
Not at all. Proof is the check, the rigorous verification that our resonance wasn't just a hallucination. But her core argument and her searing critique of the education system of her time is that schools only teach the proof. They only teach the scaffold.
They just drill rote memorization.
Exactly. They teach students how to blindly manipulate symbols on a chalkboard without ever actually understanding the underlying reality those symbols represent. She advocates for teaching insight, for nurturing the intuition first, and she fiercely believed that anyone could be taught this intuition if they were just given the opportunity.
But there's a tragic irony in her advocating for an open, intuitive education system, considering the system of her time literally barred the doors to her.
Oh, entirely.
The French Academy wouldn't let her attend lectures simply because she was a woman. She had to submit her early work under a male pseudonym, Monsieur Leblanc, just to get the professors to read her calculations.
Her commentary on this in the fragments is just searing. She writes, mathematical ability does not reside in the reproductive organs.
I mean, she's not wrong.
Right. But she experienced crippling self-doubt over the years because of it, constantly wondering if her struggles with complex math were because the math was inherently hard or because women simply weren't built for it, which, was the lie society constantly fed her.
But she pushes through that doubt anyway. Her advice to future marginalized scientists, tucked away in these unsent letters, is so stark and powerful. She essentially says, do the work. Make your work so undeniably excellent that the prejudice is worn away instance by instance, because they simply cannot ignore the sheer excellence in front of their eyes.
It's an incredibly heavy burden to place on those who are excluded, and she knows it. But it reminds us that Germain's genius wasn't magic. It wasn't some effortless divine inspiration. It was the result of intense, grueling persistence in a society that forced her to hide in the shadows just to learn.
Well, let's bring this deep dive to a close. Germain's grand, hidden manuscript leaves us with this incredible fourfold unity. Mathematics is unified, physics is unified. Mathematics and physics are one and the same, and the human mind is part of that exact same mathematical fabric. It's all connected.
We are all, as she so beautifully wrote, vibrating plates. We resonate with the universe until our physical vibration stops, but the truths we manage to reveal during our brief time here remain forever.
And I think that is the ultimate takeaway for you listening right now regarding how you approach your own curiosities. You are not some isolated outside observer trying to cram external data into a biological hard drive. You are an active part of the universe, trying to resonate with its own hidden structure.
You're a part of the system.
Exactly. When you feel drawn to a problem or a puzzle or an anomaly in your work, let your intuition guide you. Let yourself resonate with it before you get completely bogged down in the rigid proofs and the mechanics of how it's supposedly, supposed to be done. Trust the resonance. But before we go, there is one final, incredibly provocative thought hidden in Germain's papers, specifically in Fragment 9X, which contains her notes on the nature of error. We've spent all this time talking about how our minds resonate with the universe. But what if our mathematical errors aren't just carelessness or a lack of focus? What if they are biological blind spots?
This is such a fascinating concept to untangle.
Right. Just think about the human eye. We literally cannot see ultraviolet light. The light is there, it's real, but we are biologically incapable of perceiving it without special instruments.
We just don't have the hardware for it.
Exactly. So what if the human brain is simply evolutionarily incapable of perceiving certain mathematical realities? I mean, we evolved to survive on a savanna, tracking predators and finding food, not to map the infinite dimensions of space.
That is wild to think about.
So, ponder this. The universe contains infinite rooms of knowledge, infinite corridors behind those prime number doors, but we might have to invent entirely new, unimaginable tools or entirely new conceptual languages just to be able to see the doorknobs.
It's a humbling thought, but honestly also a thrilling one. It means the map is nowhere near finished. The frontier of discovery is still wide open.
The map is still being drawn, and who knows, maybe the next secret manuscript, the next dusty map waiting to be found in the archives that unlocks a whole new room of the universe, maybe it'll be written by you. Keep resonating.